Welcome back. Why does sine squared theta plus cosine squared theta equal to 1? I'm going to try to just kind of remind you of where this comes from in case maybe you have forgotten. So if you take a triangle, so this is a right angle triangle. Let's go back to how basically sine and cosine were derived. Okay, so first of all, so let's say this is my hypotenuse, all right? And I know this angle right here, let's call that angle theta of that triangle. Now, from this angle, okay, so the opposite side of that angle is this right here, I'm gonna call that O, and then the adjacent side is this right here. And you should remember that sine theta is actually defined as the ratio between your opposite length. So this is the length of your opposite side. So that's basically how long this is. And your hypotenuse. That's how sine theta is actually defined. So that's the definition of it. Now cosine theta is defined as the adjacent length divided by your hypotenuse right there. So those are the definitions of them. Now, if you take any triangle and you force basically your hypotenuse, so this length right here, and if you force this to be equal to 1, so I'm going to set this equal to 1, then you will notice a very interesting pattern, right? So first of all, we know kind of a few things. We know that from Pythagorean theorem, because this is a right angle right here, we know that the hypotenuse squared is equal to the two sides, okay, so squared, so your opposite side plus your adjacent side squared. So we know that that is true from Pythagorean theorem. So we have that. Now, if I set the hypotenuse equal to 1, so notice what happens. What happens is that your sine theta, so this right here, okay, so this is what we have here, all of a sudden becomes equal to, so sine theta is equal to your opposite over, okay, divided by 1, because that's what we're setting the hypotenuse to. Well, if you're going to be dividing by 1, then your opposite side is just equal to sine theta. Now, if you do the same thing for cos, which is right here, and if I take this, and again, so I'll do the same thing, so cos theta is equal to adjacent divided by 1, and again, because it's just divided by 1, then your cos theta is equal to the adjacent side. And now, okay, so if you take your Pythagorean theorem result, which is right here, well, if we know that the hypotenuse is equal to 1, well, 1 squared is just 1. The opposite squared, well, we've just wrote it out. This is just sine theta squared, all right, so this is squared, plus cosine theta, because that's your adjacent side squared. Now, it's just common, kind of the way that we write in math. Instead of writing sine theta squared like this, we typically just simply write it like this. This is just for convenience, but they mean exactly the same thing, so it doesn't really matter how you write it, but you typically will see it like that. And that's the reason why if you take any angle, and it doesn't really matter what that angle is. Now, of course, that angle, we're assuming that it's an acute angle in this case, so it doesn't become kind of an obtuse, because then you no longer that hypotenuse will be your hypotenuse at all. So for this, okay, so what you have is, no matter what the angle will be, you know, if you take sine squared and you add it to cosine squared of that angle, it's always going to be equal to 1. Now, that is exactly the reason why we have those equal to 1. Now, it doesn't matter. You can do it for any angle. It doesn't have to be an acute angle. It can also be an obtuse angle. You'll find kind of the same result because of the fact that you're squaring it. And, the squaring is going to get rid of any negative numbers if necessary. All right. So that's the reason why. There you have it. You can test it out on your own if you like. Put any angle that you want. And then you'll see that it always is equal to 1 when you square sine and cosine. And it comes from the fact that you set your hypotenuse is equal to 1. Okay, thanks for watching. We'll see you in a future video. Bye.